So question number 1. If y equals 7, what is the derivative? So what is dy dx? Well, 7 is a constant. That means that my function doesn't change. So its derivative will be 0. Y equals -2. The same scenario. It's although a different number, but it's still a constant. So this function's derivative, which is the measure of the change, also going to be 0. Y equals 13, another constant, so the derivative again will be 0. Y equals -150, although that's a very big number, but it's still a number, so it again doesn't change, its derivative will be 0. Number 5, a little bit of a difference now. This one is a linear function. So remember, what was the change or the derivative of a linear function? That is just the coefficient in front of the x. So that is equal to 2. Question 6. Y equals 5x minus 2. This is again a linear function. So the derivative just will be the coefficient in front of x. So the derivative is 5. Number 7. Y equals minus 2x plus 5. The derivative is going to be minus 2 because that is the number, that is the coefficient in front of x. Number 8. Y equals a half x minus 7. So the derivative equals to a half because that is the coefficient in front of x. Number 9. Minus 2/3 of x minus 4. So the derivative is minus 2/3, coefficient in front of x. And the last example, y equals 20x plus 30. So the derivative is 20 because that's the coefficient or number in front of x. So they are not that complicated. Constants don't change, so their derivative always going to be 0. And the linear function's derivative is always just the coefficient in front of x. I'm going to introduce you to one more rule of differentiation. Now, differentiation can get a bit more complicated because you can introduce then all sort of different kind of functions, product functions, quotient functions, logarithmic function, exponential functions. So if you want to take differentiation further, you can look at other videos and learn a little bit more about it. But knowing these 3 basic rules, the constant, the linear functions, and the power function that I'm just going to introduce you to, will be enough to carry out calculations in microeconomics for business. If you are interested, more than welcome to go and look into more details. But if you don't have time, don't worry, these are perfectly sufficient to help you through microeconomics for business. So what does the power function look like? Well, it's basically a to the x of n. So basically, the variable x is raised to some kind of power, and we may or may not have got a coefficient in front of it. What will be the derivative? So the rule says bring the power down and lower the power by 1. It looks a little bit more complicated than it actually is, so I'm going to go straight into some practice questions to show you how simple this is. So if my function is 2x squared, then what do I need to do to calculate or find the derivative? I need to bring the power down, so 2 times 2, and I need to lower the power by 1. So 2 times 2 makes it 4, 2 minus 1 makes it 1, but x to the 1 is just x, so the derivative is actually 4x. Second example, y equals 5x cubed. So what is the derivative of this power function? Rule again, bring the power down and lower the power by 1. 3 times 5 makes it 15, and 3 minus 1 makes it 2. The third example is y equals 3 to the x half. So dy dx then will be bring the power down and lower the power by 1. Now 3 times a half gives me 3 halves, but what is a half minus 1? I'm going to calculate here. A half minus 1. When I need to take away fractions, I need to make sure that they have the so-called common denominator. So a half take away, I need to change the 1 into halves. So how many halves there are in 1? Well, a whole is 2 halves. So it's basically 1 half minus 2 halves. So a half minus 2 halves is basically going to be equal to a negative half, because I don't have enough to take 2 away from it. 1 minus 2 gives me negative 1, and halves taking away gonna give me minus half. So the power will be minus half. Number 4, y equals minus 6 times x to the minus half. So the derivative, again the rule, bring the power down and lower the power by 1. Multiplication, and I kept the bracket because I'm multiplying negative numbers. So negative times negative gives me positive. 6 times a half is 6 halves. And again, what is the power? So minus a half, take away 1. I again have to go through the same process of having this common denominator. So minus half minus 2 halves, which is my whole. Now in this case, what happens now? I have got a half, a negative half, and I'm taking away 2 more of those halves. So I was already in debt and I'm paying more money out. So altogether I'm going to end up with minus 3 halves. And the last thing to spot here is that 6 over 2 is just 3. So it's 3 times x to the minus 3 halves, or minus 3 over 2. And the last example, y equals 2 over 5 x to the minus 5. So what is the derivative here? Well, bring the power down and lower the power by 1. So let's tidy this one up. Negative times positive makes it negative. 5 times 2 over 5, the 5 can cancel out. And what will be the power? I've got £5 debt and I'm paying out 1 more pound, so I'm going to end up with negative 6. So minus 5 take away 1 gives me negative 6. So the final answer in nice and tidy format is minus 2x to the minus 6. Now I kept to this very detailed writing out of following through the rule. If I was to do it myself, I wouldn't bother writing these things always out, because I know that minus 5 minus 1, it gives me negative 6, so I could actually skip this step. But I suggest that until you become very familiar with how these rules work, try to detail them out as much as it's helpful for you. If this one is too much and you find it's just confusing you, then don't worry about it, just write out minus 6 straight away, which I'm probably going to refer back to later on when we start to carry out the exact calculations. Now, there are a couple of more rules that I would like to introduce you to, but they're not necessarily any difficult rules. Basically, what these rules are telling me is if I have got a function that is a sum or a difference of 2 functions, then I can differentiate them term by term. which is quite useful because applying the previous rules that we learned, the constant, the linear and the power rule, just looking at each terms and see, okay, is this constant, is it linear, or is it a power? And then I could apply those rules to that particular term, move on to the next one, and then go through the same process again. So let's look at some examples. So y equals 7x squared. Well, there's no sum or difference in here, so I can just simply apply the power rule. So dy dx will be, bring the power down, so I would have 2 times 7, which I can calculate in my head to be 14. And what will be the power of x? 2 minus 1 gives me 1, but the power of 1 we hardly ever write out, so that's the final answer, 14x. Nice and simple. Let's just look at a couple of more of these examples to sort of get used to how to write them quickly. So if y is equal to minus 2x cubed, then what will be the derivative? Well, negative times positive gives me negative, 2 times 3 gives me 6, and then the power is 1 less than 3, which is 2. Third example, if y is equal to 13x to the minus 5, then what will be the derivative? Well, again, bring the power down, but that means I'm going to have to multiply a positive and a negative together, so that gives me negative. 5 times 13 is 65, and the power of x is minus 5 minus 1, which is minus 6. So this is how you can write out using the power rule without having to detail all these exact calculations and still having the same answer in a shorter, quicker way. Now let's move on to the new rules, the sums and differences. In example 4, y is equal to minus x squared plus 4x minus 10. So what's the derivative of this function? Let's look at it term by term. So the first term is a power function. So what I need to do, I need to bring the power down, so that will make it minus 2. And the power of x will be 1, which we don't write out, plus. These two terms together is a linear function. And the linear function's derivative is just the number in front of x. Remember, this is a constant, and constant's derivative is always 0. So that is the derivative of this quadratic function. 5. Y equals 2x to the 5 plus 3. So what is the derivative of this function? So again, looking at the first term, that is a power function. So the power rule says bring the power down and lower the power by 1. So if I bring the power down, if I bring the 5 down, 2 times 5 makes 10, and lower the power by 1, 5 minus 1 makes it 4. The second term is a constant, and constant's derivative is 0. So the derivative is just 10x to the 4. 6. Y is equal to 5x to the minus 2 minus 2x plus 17. What's the derivative of this function? Well, we can again look at it term by term. The first term is a power function, so bring the power down. Minus 2 times 5 makes minus 10, and lower the power by 1. Minus 2 minus 1 gives me negative 3. Remember, you were already in £2 debt and you paid out £1 more, so your debt increases. That's why we got minus 3 there. The middle term, minus 2x, its derivative, x's derivative is 1, so minus 2x's derivative will be minus 2 times 1. So that's minus 2. And the constant, the plus 17, its derivative is 0 because constant doesn't change. So the derivative of this function will be minus 10 x to the minus 3 minus 2. So example 7, y is equal to minus 2x to the 0.5 plus 5x. So what is the derivative of this function? Again, what is the rule? Bring the power down, so that will be minus 2 times 0.5. But you remember that 0.5 is half, so what's the half of negative 2? Well, that's just negative 1. And remember, we don't write the 1 out as a coefficient, so I can just write negative x. And now lower the power by 1. So 0.5 take away 1 will give you negative 0.5. Remember, you've got 50 pence, you're taking away a whole pound, you end up with 50 pence debt. So to the power of minus 0.5 plus, what is the derivative of 5x? Well, x's derivative is always 1, and 5 is a constant multiplier which stays, so the derivative of 5x is 5. And the next example, example 8, is y equals a half x to the minus 0.5 minus 7x plus 2. So again, what is the derivative of this function? We can look at it term by term. So the first term is a power, so we need to bring the power down, but we remember that 0.5 is a half. So positive times negative will make a negative, and a half times a half. Remember, when you're multiplying fractions, you need to multiply numerator by numerator and denominator by denominator. So a half by a half gives you a quarter. And what's the power? Well, minus 0.5 is the original power. I need to lower it by 1. So minus 0.5 take away 1 gives you minus 1.5. Again, remember that you are already in 50 pence debit and you're paying 1 more pound out. So altogether you're ending up with £1.50 debit. Now we can look at these last two terms as separate terms, or we can remember that this is like a linear function. And remember that a linear function's derivative is always just the number in front of the x. So minus 7. And remember, in other ways, that the positive 2 is a constant, and constant's derivative is always 0. So that's why we don't write that out. Two more examples. Example 9. Y equals minus 2/3 x cubed minus 4x to the minus half plus x. So what is the derivative? Again, bring the power down. Positive times negative will make it negative, and 2/3 times 3. Dividing by 3 and multiplying by 3 cancels each other out, so I'm just going to end up with the negative 2. But what will be the power of x? 3 minus 1 gives me 2. Second term, it's negative, but I'm bringing the power down, which is also negative. So negative times negative will make it positive. And 4 times a half, or a half of 4, is 2. So what will be the x's power? Minus half take away 1 gives me minus 3 halves, or minus 1.5. And what's the derivative of x? Remember that this was a special case. X's derivative is always 1. And the last example. Y equals 20x cubed plus 30x squared. So look at the derivative. Well, after all those fractions, these ones are quite simple. 3 times 20 gives me 60. X's power become 2, because that is less, because that is 1 less than 3. 30 times 2 gives me 60 again, and x squared becomes x, because 1 is 1 less than 2, but the first power we don't write out. So these are the general mathematical rules of differentiation, and these examples were intended to help you to learn the technique of differentiation. But the final goal is not just learning the technique of differentiation, but to be able to apply it in the microeconomical concepts.